if you're year 12 and 11, here's the next example on how to find the equation from the graph. Okay, this is the trajectory of a paper plane. What we're really interested in is the boring question of what equation formed the trajectory. Okay, so what you might want to do is to let's look at the green one first and decide how we're going to model that. So it looks like it's probably an upside down parabola, so we're going to go with that. If you're not quite sure about that, here's an easy way to spot a pattern. So remember back in year 11 we did this with the out 1, up 1, and then out 1, up 3. In here, just looking at the pattern here, we can see we're out 2, down 2, and then we're out 2 squares, that is, not 2 values. So out 2 squares, and then we're down 2, 4, 6. Right, so that looks like double the pattern there. And for many of you, that will be enough for you to go straight to writing the equation. Okay, so we're going to look at that one first. I just want to erase all those little squiggles before I make more mess. So let's get rid of those. Okay, so while I'm doing that, if you want to try writing down what you think that parabola has as its equation. And here we're going to use the transformation properties that we know. So the basic form of a parabola is y equals x squared. If I reflect that in the x-axis, I get y equals negative x squared. So that would be the parabola that went like that. Now, what's happened to this one is that it's been shoved that way, and then it's been shoved up. So that's the first couple of things, and then it looks like it's been squeezed. Right, so let's do the form. So it's going to be negative k times x minus 4 squared. So that would get me, the minus 4 part gets me shifted out to here, and then the plus 4 shifts it up to here. As I said in my class, it doesn't matter if you write this as negative k here, or you could write it as k, x minus 4 squared plus 4. In either case, what we're left to do is to work out what is the squeezy stretchy factor, also called the scale factor. So to do that, I need to pick a point, and it needs to be a point that isn't the vertex. Okay, so I'm going to pick, well, there's a really easy one to pick here, which is the intercept. So we know that 6, 0 is on the curve, so we substitute that in. Right. I'm going to use this version of the equation where I've said negative k. I like doing it that way because it reminds me that I've got an upside down parabola, but it all comes out in the wash anyway. So we get 0 is equal to negative k times 6 minus 4 squared plus 4. So 0 is equal to negative 4k, because this in here is 2 squared, which is 4, plus 4. So we get 4k equals 4 and k equals 1. Right, so my equation is y equals negative x minus 4 squared plus 4. We just want to check that that's right, and we're going to do that by looking at another point. So let's look at what happens when x is 5. So we know that we should get the value 3. Let's see if it works. So negative 5 minus 4 squared plus 4. What does that equal? Well, that's negative, we do this bit first, and so it's negative 1 plus 4, which is indeed 3. So we should be happy that we have found that equation. Okay, and just one more time, the transformations that got us to it from the basic form are first, that we reflected in the x-axis. Second, that we shifted, whoops, I've gone too far, shifted out 4 units. Then we shifted up 4 units, and then we didn't do any squeezing or stretching. Okay, so there were 3 transformations in there. On the next slide, I'm going to do the red part of the paper plane trajectory. Alright, so one way to decide what we should use as a base model here is to just take a look at the shape, and we could turn our computer on its side, or especially if you've got a tablet or a phone, and we could see that it looks like a sideways parabola. So that suggests that we're going to have a functional form which is some variation on the square root graph. Now we can see that it's been shifted up 2 units from the basic one, so our form is going to have a +2 on the end. Every point, every y value has been increased by 2. And the other thing I don't know is what's the squeezy stretchy factor. So there's no sideways shift, I don't need to worry about that. So we can model this like this. Y is equal to the square root of some squeezy stretchy factor times x plus 2. So we can put some points in. We've got a point here which is 1, 3. Then the next blobby point is going to come at 4, 4. So let's work with 1, 3. Well, we've got 3 is equal to the square root of k times 1 plus 2. So 3 is equal to the square root of k plus 2. 1 is equal to the square root of k. K equals 1. It's telling me that my function is just y is equal to the square root of x plus 2. Right, let's check that with another point. Let's look at whether this one is in fact on that curve, and we see that the square root of 4 plus 2 is equal to 2 plus 2, which is equal to 4. So that all looks good. Okay, that's all for now. 2 more to come.